we're going to talk about Chapter 9 a bit, and it's getting into the real content portion that we need to gain an understanding of as we talk about application of chemicals and so forth. And the title of this one is Application Equipment, Calibration, and Methods. So we're probably going to spend a little more time on this one because there's several different resources that we can pull up from it. But you know, as what I've done in the past few chapters, spend a few minutes on the terms that are talking about here. Some of this is redundant. We've already talked about it with the active ingredient. That's a chemical that's in a pesticide product that affects or controls the target pest. And, you know, that's, you know, hopefully you'll understand what that one is. But the application rate is a term that describes the amount of pesticide to be applied to a given area. And on most labels, most the commercial chemical labels, that application rate is given in pounds per acre, or it may be gallons per acre, depending upon the formulation of the material that we're talking about. Now, some of the newer chemicals that have come out on the market in the past 5 or 6 years are chemicals that will have much different application rates. There's a couple that I used in the vineyard this summer that will have an application rate of 1 ounce per acre. It's 1 fluid ounce per acre, or 1.5 ounces actual dry weight ounces per acre. And, you know, part of the concern that we have as we talk about application rates and equipment and so forth, when we get down to that type of material, we can't afford to make any mistakes. We've got to know what we're doing as we do that. You know, so when we're talking about 1 or 2 ounces per acre, it's really a matter of concern as we talk about the application equipment, the application rates. So, you know, if I give you a task of applying, say we're going to be, you know, really liberal and use 2 ounces per acre, how would you apply 2 ounces of a dry material on 43,560 square feet? Carol, how would you do it? Paintbrush? Squirt gun? I'm not expecting an answer. That's just something for you to think about how precise that some of this stuff has gotten. And there are types of application equipment that are much more sophisticated than the equipment that I have experience with. There's a lot of stuff out now that's using GPS, and they're just really heavily involved with the technology of putting this stuff out. And that's, you know, what I was doing was using an ounce per acre. I was applying about 200 gallons of water per acre. So I would put that ounce of material in 200 gallons of water, which, you know, wasn't enough to even color the water. But you do what you can to effectively disperse that 200 gallons of water evenly over the acre. Tom, we're getting a little bit of background noise, sort of static. I don't know where it's coming from.
It's probably these speakers. They're
okay
in here.
That's fine. That's fine. I didn't know, you know, the source, and didn't want to be missing out on anything. But,
Mr. Ayers,
yes, ma'am.
so when you apply that to that big of piece of land, are you walking through you would be riding through with one of the plastic
Yeah.
or in like a crate thingy?
Well, what I was using was actually a trailer type piece of equipment that's got a big fan on it. It's an air blast machine, and we're going to talk about some of that type stuff as we move through this chapter. That's a whole lot of what we're going to talk about, because when you ask the question, and it's a good question, because that gives me an idea of what your thought processes were. That acre to you seemed like a large volume or large amount of land to cover, but really, when we get into commercial agriculture, that's a really small area.
When we were at the parish pumpkin patch,
Right?
the owner, I can't remember his name, the older gentleman that had owned.
Yeah, I can't remember this.
But he had showed us that in the pest that he was targeting for cucumber beetles.
Cucumber beetle, little striped cucumber beetle, yep.
Get under like the leaves and hide under
Right.
there. So
yep.
This year he had bought like a blower type thing where it sprays it out and gets it underneath the leaves. I don't know how they roll it along. I don't know.
They hook it up behind a tractor. It hooks up to the PTO, but it's a giant fan that blows. I can't remember how fast he said it blows, but it also has nozzles there. So it's blowing up the leaves, and then the spray is going to get under to spray the underside of the leaves to get the beetles.
It looked like a cone. And then the opening was there with little sprayer pieces
Yep.
Three.
Yeah. Yeah. What he had probably didn't have an actual nozzle in it. It had an orifice, which would emit a volume of the chemical solution into that air stream, which would project it. It's actually being delivered by the air rather than high pressure. But as we move along through this chapter, that was one reason I said we're going to spend some time on it, because there's so many different types of equipment, and it's changed over. Science has brought about changes in this stuff, and from this class you need to be exposed to a lot of the different types of pieces of equipment. So we're going to spend some time on it. But that, I'm glad you had that experience, that you could see that. That's a good one. That reminds me of it's been, I can't, when I go to thinking about it, it's probably been 15 or 20 years ago. When I had the market in Greensboro, we did a lot with kids this time of year wanting little individual pumpkins, and at that time it was hard for me to get the little small pie pumpkins, little 3 or 4 pound pumpkins. So I found a source up in the lower portion of Albemarle County with a guy that he was actually the son of an apple grower up there, and so I made arrangements to go up there and pick up a load of these pumpkins from this kid. And when I got up there, he had probably 60 or 70 acres of pumpkins in a river bottom.
Wow.
And when I pulled up, trying to think of the kid's name, I believe his name was Ben. But I said something to him about his pumpkin vines looked a little bit rough. And he says, "Well, yeah, I don't know what's the matter." He said, "I've been spraying them every 10 days, and the downy and powdery mildew had totally taken the leaves off of his pumpkins. All he had was some little stems and a little bit of vine, and then a field full of naked pumpkins that hadn't really finished, because they had lost their leaves to these 2 fungal diseases." And as I questioned him, he had a 1,000-gallon tank, plastic tank, that he was pulling behind a large 4-wheel drive tractor that had booms, a boom type nozzle system that extended probably 50 feet, 25 feet on each side. And he was so proud of his spray and so forth, but it was obvious that it hadn't done the job on this pumpkin field. And as I talked to him, he was the son of an apple grower that I did know, and he and his dad didn't get along, and he had gone out on his own to grow pumpkins, and he was proud of this piece of equipment, and he said that he sprayed it every 10 days, and I said, well, Ben, how much water are you putting down? And he said, well, I can take that 1,000-gallon spray and spray this 100 acres that I've got. And as a quick calculation, he's putting down 10 gallons of water on an acre. So 10, do what?
So that's on the drought number.
10 gallons of water on 43,560 square feet.
That sounds like a drought.
You can spit more than that, Tyler. It didn't even put a mist on. Nothing. It didn't wet him. That was the problem with his disease control. He may have been using an adequate amount of chemical, but his delivery method was.
Wait, you said 10 gallons over an acre?
Yes, sir.
Oh no.
Yeah.
Okay.
10 gallons in an acre. So it was not. He had a piece of equipment that would do the job had he slowed down and put 10 times that much material of water on to wet it. But these chemicals are only good as good as the mechanism that you use to apply them. So that's part of the point that we're going to make with this chapter is to try to make sure that you're able to match the equipment or application that you've got to the crop and the disease that you're trying to control. So that was one of the issues that Ben had. I haven't talked to him since, but along the same lines, I've got good friends that are just north of Halifax, and they were running into issue with the cucumber beetle, Carol, on their watermelons and cantaloupes this year, and they called me and wanted to know about particular chemical to use, and I said, yeah, I can get it for you. And I don't remember what it was now, but it was a pretty toxic insecticide that was used to control cucumber beetles. They had been using something like malathion and 7, which is fine for a home gardener, but if you've got 50 acres of cantaloupes and watermelons, you need to have a little more ammunition in your gun than that. So as we talked a little more, I kept questioning him about what kind of equipment they were using to put it on. And there again, they were using a boom spray, which is a long device and had a pump, and it just spraying it right down on the top. But as you said, as Mr. The gentleman told you, the insect was on the underneath side. And in their situation, they were actually underneath the cantaloupes and the watermelons, and they were chewing on those young watermelons and cantaloupes enough to greatly disfigure the cantaloupe. Didn't damage the interior portion of the cantaloupe, but the rind looked almost like it. Well, I can't imagine. Looked almost like it had some sort of disease. It had distortions, and it just looked like sort of like it had termites, for a better way of describing it.
It's something no one is going to buy.
It deterred the cantaloupe was great, flavor was there, but the appearance, and people buy with their eyes, and so it didn't look as good. So I managed to help them get the material that would do the job, but I had a 300-gallon speed sprayer that I wasn't using, that I took to them so they could do like what Mr. Parrish was saying. It would blow the leaves over and be able to get the material into where the insect was. And over the course of the summer, it's greatly improved the quality of the product that they had available for sale. In other words, they stopped having any issues with the appearance on those melons. So, but it's, and that's what we're going to talk about as we move along through this portion of it.
Also, apologies for being late, sir. I had to help rescue a dog.
I hope you were successful.
He was talking around 30 blocks and almost fell in a ball.
Okay, as we talked about the application rate, that's the amount of pesticide in a given area. A band application is an application to a long, narrow strip. Quite often it's done right over a row of a particular crop. A broadcast application is a more uniform application over a wide or large area. And that's generally what I do with my grapes. I'm doing a broadcast application. You know?
Broadcast as one word or broadcast as in a broadcast?
It's a single word. Broadcast. You're talking about it's actually a verb in the way that you do that.
Okay.
Okay. The term calibrate, it means to measure the delivery rate and distribution of the application equipment, or to adjust the application equipment so that the desired amount of pesticide is applied uniformly to a given area. And calibration is a key factor in the success of the use of any chemical. And I started to say agricultural chemical, but it's more than agricultural chemicals. And it depends totally upon the type of equipment and the crop that you're using to apply. My grape vineyard, for example, I know that the 400-gallon tank that we use will spray about 200 acres. Not 200 acres, 2 acres. So I know I'm putting on about 200 gallons of water per acre. You know, and I can change the pressure on the spray machine, or can change the nozzles. If I reduce the orifice in the nozzle, that's going to make the mist much finer and change the amount that you put on. What Tom's got on there is that's a tank.
That's the sprayer we were talking about.
It perishes?
Yes.
Okay.
I don't know if you can see over here's the I don't know if you can see my mouse. Let me see if I can over here on this end is where the blower is, and there's like a hose that goes around the end with a valve and hooks up to the PTO there.
Yeah, okay. What he's talking about, this is the area for my folks here. This is the area that's going to have the air coming out, and the blower, the fan component is in the back. I've got there's some things that are included in the PowerPoint that Tech has that we'll look at as we move along through this. But calibration is a key thing, and we're going to spend some time talking about calibration and how it's done and things of that type, because it's totally different with every piece of equipment that you use. And there are actual formulas and systems that you need to do to be able to calibrate a particular sprayer. The term carrier, that's not a bucket or anything like that. That's the primary material used to allow the pesticide to be dispersed effectively.
Inert ingredients?
Well, it can be considered inert ingredients, but a while ago, before you got here, we were talking about applying 2 ounces of a pesticide per acre. And in that situation, the carrier you'd have to mix it with something, and that we would mix it with water. So in essence, water is the carrier in that situation. Okay?
So the carrier can be the inert material that's used as filler, but it's not necessarily.
That's right.
Okay.
Yeah. Examples include the dust formulation or tank or water mixed with the wettable powder before a spray application. The air disperses a pesticide in an air blast application. So in the machine that Tom just showed you there, the primary carrier was the air in that one. Okay, we talk about concentrated materials. They are materials that have a high percentage of the active ingredient. Um, Then we talk about a directed application. That's a precision application to a specific area or site. Could be an underleaf, it could be a fence line, could be a guardrail, would be a directed application. I'm sure all of you have seen this, you know, during the summer, the state has a truck that will go drive down the side of the highway, and they've got a boom system mounted on their front bumper. And it's directing a sort of a fan type of arrangement of nozzles that go over the guardrail along a lot of the highways. And this is particularly effective against Johnson grass. Johnson grass is a noxious weed that has become very prolific in the area, and thank goodness the state's doing some of that. The Johnson grass was not planted there. It's a weed that the birds have actually planted. They've relocated seeds, and the birds are going to sit on the guardrail, and the deposits that they make, the excrement, will have Johnson grass seed in it, and it falls down the base of the guardrail and it germinates, and you'll find 5 and 6 foot high patches of Johnson grass on the edges of guardrail.
Johnson grass, that stuff that kind of looks like corn at one stage of its life.
It does, and it's a terrible weed, and it doesn't hurt so much except it limits visibility. If you get to the end of a particular section of road, and you've got to make a turn at an intersection, and that guardrail is got 6 or 7 foot Johnson grass on each side, you can't see where you're going to go. So it's a safety thing as far as the state's concerned. We talked about drift. That's the aerial movement away from a release site. Drift is a primary concern. A drop spreader. That's a piece of application equipment that I'm sure all of you have seen. Some of you may have used. You know what I'm talking about with a drop spreader?
Yes, sir.
When you're pushing it along, it's just spraying seeds everywhere.
Well, no, it can spray seeds, but that's not a drop spreader. A drop spreader is one that it's usually used to disperse fertilizers or herbicides along a lawn. It is a little vessel that you put the material in, and you do push it, and it just drops out. There used to be a lot of old lime spreaders that were drop spreaders that were used 40 or 50 years ago. That was one mechanism that farmers were using to disperse lime. It was just a type of, it's gravity fed, and it just drops it and meters it out as you move across. So,
what is the type of device that when you're pushing it beneath it has like a spinning thing?
It's another type of spreader. Usually those are seeders, but
yeah, I remember back when I was a kid, my parents used a few of those things to spray grass seeds all over the yard.
Mm-hmm. You can use for grass seed. You can use them for herbicide control. Some people use them for fertilizer and lime, but that's a little different than a true drop spreader. Effective width, swath width, is the span from which spray or granules with enough pesticide to control a pest. That's a little different use of those terms that you don't normally see. The term flow rate is the volume of material released per unit of time. The amount of fluid that passes through a nozzle's orifice in 1 minute could be construed as a flow rate, and it could be a difference. It doesn't have to be a minute. It could be 15 seconds. It could be 30 seconds. But this is something that we use when we're doing our calibration. We need to know what the flow rate is. Quite often, flow rate is done on several nozzles to determine if they're all uniform. Gallons per acre. That's a term we used a little bit a while ago. That's the volume of liquid applied to an acre unit of area. How many of you know what an acre is? I'm not talking about a sore tooth. What's an acre?
Measure of land.
Mm-hmm. Measure, Tyler says to measure of land. That's true. How much, Tyler? What was that, John? Did he say?
Is it 70 yards by 70 yards?
That's close. That's close. If you're stepping it off and you want to determine an acre, that's a pretty decent approximation. But a true acre is 43,760 square feet.
43,000.
260 square feet. 43,260. I may have said 7, but it's 2. I misspoke.
Okay. Thank you.
Do what?
I said, how dare you compromise our education?
I know it, Tyler. But you should have caught me on that one. You messed you up by 500 square feet. All right. Gallons per minute is another thing that we need to be aware of when we're talking about calibration, and that's the volume of liquid released by a spraying system or a specific nozzle over a period of time, and usually it's over a minute. Well, if we're talking about gallons per minute, it is per minute. But you can measure it in terms of 15 seconds or 30 seconds, depending upon what you were doing, and then you multiply it by either 2 or 4, whichever is appropriate. All right. What's an orifice? Amanda, what's an orifice? You have an orifice there with you right now? She's holding her head and laughing at me.
Okay. An orifice is an opening as of a pipe or tube or one in the body, such as, oh, I'm not going to go there, but it's an opening hole, a slot, or a slit.
Yeah. It's a precisely sized opening in a spray nozzle, duster, or granular applicator. And I was picking at Amanda because she's sitting here with a Sprite bottle. That Sprite bottle has got an orifice. That's the opening in which the pop comes out. Okay? That's how simple it can be. Generally, the orifice on different spray machines, it varies with the type of machine we're using. And the one from Mr. Parrish's, it wasn't a nozzle, if I could see that correctly. It's actually just a little hose of a device that puts that spray solution out into a volume of air that machine is generating because of the high-speed fan that it has, and it's being directed through actually a flume, and that inside that flume there will be that little tube, which is the orifice. That's the little opening that all of that liquid will go through. Okay, a release, that's the discharge of a pesticide from its container or the equipment or system used to apply it. Release can be intentional, as in the application, or it can be accidental in the case of a spill or a leak. You always want that release to be intentional instead of accidental. I've got one spray at home that I'm going to have some work done on it because it's a stainless steel tank and it's begun to leak a little bit. So I got to take it to my friendly welder and have him do some work on that tank. Tyler, your discussion a while ago of the type of spreader, it's a rotary spreader, it's a type of granular applicator that distributes granules to the front and sides of a spreader, usually with a spinning disc or fan. That's what we're talking about. A rotary spreader as compared to a drop spreader.
A drop spreader, it's set up to, after certain distance, just open up a little vein log and just drop it out. It looks like a bucket
Well, it can look like a bucket. It looks more like a little trough generally. Some of them can be bucket shaped. Yeah, they can be. Yeah. So, spot treatment is the application to a small localized area. In some cases, spot treatment involves treating individual pests, such as thistles in a pasture or a yellow jacket nest, while avoiding non-target organisms. Thistles used to be a major concern for folks that were grazing cattle. Cattle will not eat around a thistle plant. And there were, at times folks would send people out with a mattock or a shovel to dig up thistle. But they've come to learn that it's much more efficient and timely to take a small handheld sprayer and apply some type of herbicide on that spot treatment where that thistle is. It'll kill the thistle, and then the animals will again begin to graze. Do your horses graze where there are any thistles? Have you got any thistles in the pasture? Do you know?
I don't know.
You'd know. You'd know if you did. You'd know. Spray volume is the amount of finished pesticide mixture to be applied per unit area. So it could be, we're talking about the spray volume to spray inside of a greenhouse. That would be 1 unit area. If you're talking about spraying my vineyard, that would be per acre. That's another one. Like the guy that I was talking about that had the pumpkin patch, he had about 100 acres in the bottom there. So that would be the area that he was going to be sprayed. The swath is the area treated by application equipment in one pass. If we're talking about a boom sprayer that's 15 feet long, the swath of the application would be 15 feet. That's the length of the boom. Now, some of these speed sprayers and more air blast type sprays, that swath may be a little bit harder to define because they're spraying it over a wide area. A swath width is the side-to-side measurement of the band or strip of pesticide released by the equipment. So that's simple just measurement of how far that area is being wet by that material. Then we talk about volatile. That's evaporating rapidly or turning easily into a gas or a vapor. As we talk about volatile, do any of you have any experience with anything that's volatile?
Besides my wife?
I believe that's a different definition, Tom.
What about
I don't want to go there.
cooking
And
and water?
Every one of you have experience with something volatile if you got to school today.
You got like
Gasoline.
gas emission.
Petrol fumes.
What'd you say, Carol?
Actually,
What? I think you tried to get his name.
Yeah.
John.
what?
Jonathan.
Jonathan said,
Gasoline.
yes.
Gasoline, right. Tyler said the same thing. I just want to make sure. But yeah, and that's a wonderful example of something that's volatile. Now, we hopefully don't deal with many volatile pesticides,
All right.
but there are some. I've told you about a material called Command, which is a herbicide that's being used by some tobacco growers, and it's extremely volatile, and you can't see it as well as you can the vapor from gasoline. If you see the vapor coming off your gasoline tank when you fill it, you can see that little wiggly distortion as you look through that area. But Command, you don't see anything until you see the damage on the trees, 6 or 8 weeks later. There's the volatile fumes of that material will eliminate or reduce the chlorophyll in some of these trees that are surrounding an area of where tobacco has been planted or the command has been used. So if you ever see that, you'll know what caused it. But that's a volatile material that the fumes have traveled off site. 2,4-D is another material that has an element of volatility about it. I don't know whether there's much 2,4-D used in your area or not. It's an old phenolic type of herbicide, and there are two different formulations of 2,4-D. There's an ester and an amine. The amine is not as volatile as the ester, which is the oil formulation, but it will move off site, particularly in conditions that are warm, clear, and has some wind. It has been known to damage a lot of plants that are on the perimeter of areas where it's been used. Used widely in the control of broadleaf weeds and pastures, and it can be used to control broadleaf weeds in corn because it only affects broadleaves and it will not affect corn if you apply it correctly. You get the corn a little bit too young or the rate a little bit too high, it'll cause the corn to lodge. In other words, it'll make the stem pretty brittle, and sometimes it'll fall over, create a twisting of that. But it's another chemical that has a wonderful function and use as long as it's used correctly. But if it's misused, you get into a situation like a gentleman that I knew. He ended up buying a lot of ornamental plants from several homes that were adjacent to a field that they tried to control the broadleaf weeds in one spring. That volatility killed all the dogwoods and azaleas and rhododendrons that were on 3 home sites that were next to it. So, I'm going to see if we can. We got about the right amount of time to see if we can look at the video that's associated with this, and then when we get back together on Wednesday, we'll look at some different types of equipment.
Do I need to get my pillow?
You're what?
Do I need to get my pillow?
No. Rachel's got a big hat pin. She'll keep you awake. And Tom, if we run into problems, text me. Let me see if this is going to work. But
Okay.
That reminds me. Mr. Scales, did you get my email last night?
that's another topic, another class.
Yeah.
Okay. All right, I'm going to see if this will work. All right. It's not working.
Welcome to Mixing, Loading, and Application, presented by Pat Hipkins, Senior Research Associate and Assistant Pesticide Coordinator at Virginia Tech Pesticide Programs, and adapted from Applying Pesticides Correctly, Unit 10. Now here's Pat to discuss Mixing, Loading, and Application.
Mixing, loading, and application are the most common, most time-consuming, and arguably the most dangerous pesticide handling tasks. A lot of what we'll talk about during this Micromedia Breeze presentation is truly common sense. However, it never hurts to sit back, stop, and think about what you're doing. I don't know about you, but often I make my biggest mistakes when I take for granted that I know what I'm doing. So let's take some time to talk about mixing, loading, and application. We're going to talk about mixing, loading first and application second, because the risks and hazards involved with these two different sets of practices are somewhat different. Nonetheless, both are directed by what you read on the label. Mixers and loaders who handle concentrate, especially Concentrates that are high in acute toxicity have high risk. Regardless of the toxicity of the product, here are some simple steps to think about when you're mixing and loading. Risk is equal to toxicity times exposure. Therefore, to reduce your risk, you can reduce the toxicity of the products you handle, reduce your amount of exposure, or both. Reduced use means less mixing and loading. And choosing low toxicity products whenever possible also reduces the toxicity part of the equation. Here's an example of right-of-way applicators who are spraying only those trees that will grow tall enough to interfere with the power lines. They're not broadcast treatment spraying wall to wall. Therefore, they're using less product. Simple as it sounds, your first line of defense in protecting yourself and the environment is just plain being careful. Engineering controls, even simple ones like water-soluble bags, are designed to minimize or eliminate handling exposure. Your protective clothing and equipment is your last line of defense. It's there in case of an accident or an engineering control failure. Formulation choice can have a lot to do with exposure risk. For example, liquid formulations are easy to pour, measure, and mix, and in some cases are easier and neater to handle than some dries. On the other hand, if they are spilled or splashed onto your skin, they're more likely to be absorbed, and arguably, liquid spills are harder to clean up than spills of dry formulation products. Dry formulations have the advantage of reducing the risk of skin exposure. Unless your skin is moist or wet, they don't stick and they're less likely to be absorbed. They're fairly easy to clean up, too. They're not always easy to measure, mix, and load, however. Some of the newer formulations, like dry flowables and water dispersible granules, offer some of the advantages of both. If you handle large volumes of product or high toxicity products, or both, consider closed systems, enclosed application equipment, and some kind of containment. These are excellent investments for people who have high exposure risk. Have a plan and use the product label to guide you.
They can't see
when
it.
you're planning for both short and long.
Can you hear me now, Tom?
Yes, we hear you.
Couldn't see it at all?
Nope.
Dadgummit.
Yes. Would you probably like, before you start playing, just be hitting the buttons until we can see your computer screen and then. So that,
Well, that's what I did when I got started with it this time. I thought you could see it, and I didn't have it where our people could see it.
oh,
But
nope.
Where is this?
It's all Carolyn's fault.
Carolyn's fault.
I can't
Yep.
fix everything.
Well, we can't blame it on Rachel because she wasn't here when we started.
Yes. No, it's all her fault because she wasn't here when we started.
Oh, okay. All right. She
Rachel.
brought the instructions and didn't have them. All right, let me try again and see if you can see my computer. That's going to be maybe a key.
Okay. I think part of it's sometimes when they switch to the computer, then they can't hear us through the microphone, even whether I'm muted or not. Nope.
Nope.
Nope. Yes.
All right, he says yes. Okay. All right, let's try that. But in doing that, let's see where we go.
Mixing, loading, and application are the most common,
Okay. There we go.
most time-consuming, and arguably the most dangerous pesticide handling tasks. A lot of what we'll talk about during this Micromedia Breeze presentation is truly common sense. However, it never hurts to sit back, stop, and think about what you're doing. I don't know about you, but often I make my biggest mistakes when I take for granted that I know what I'm doing. So let's take some time to talk about mixing, loading, and application. We're going to talk about mixing, loading first and application second, because the risks and hazards involved with these two different sets of practices are somewhat different. Nonetheless, both are directed by what you read on the label. Mixers and loaders who handle concentrate, especially concentrates that are high in acute toxicity, have high risk. Regardless of the toxicity of the product, here are some simple steps to think about when you're mixing and loading. Risk is equal to toxicity times exposure. Therefore, to reduce your risk,
It's a test
you can
question.
reduce the toxicity of the products you handle, reduce your amount of exposure, or both. Reduced use means less mixing and loading. And choosing low toxicity products whenever possible also reduces the toxicity part of the equation. Here's an example of right-of-way applicators who are spraying only those trees that will grow tall enough to interfere with the power lines. They're not broadcast treatment spraying wall to wall. Therefore, they're using less product. Simple as it sounds, your first line of defense in protecting yourself and the environment is just plain being careful. Engineering controls, even simple ones like water-soluble bags, are designed to minimize or eliminate handling exposure. Your protective clothing and equipment is your last line of defense. It's there in case of an accident or an engineering control failure. Formulation choice can have a lot to do with exposure risk. For example, liquid formulations are easy to pour, measure, and mix, and in some cases are easier and neater to handle than some dries. On the other hand, if they are spilled or splashed onto your skin, they're more likely to be absorbed, and arguably, liquid spills are harder to clean up than spills of dry formulation products. Dry formulations have the advantage of reducing the risk of skin exposure. Unless your skin is moist or wet, they don't stick and they're less likely to be absorbed. They're fairly easy to clean up too. They're not always easy to measure, mix, and load, however. Some of the newer formulations like dry flowables and water dispersible granules offer some of the advantages of both. If you handle large volumes of product, or high toxicity products, or both, consider closed systems, enclosed application equipment, and some kind of containment. These are excellent investments for people who have high exposure risk. Have a plan and use the product label to guide you when you're planning for both short and long term, meaning what you need for one application and what you need for a season. Be sure you have the right people and equipment for the job. Be sure all handlers are, number one, able to perform the work, number two, properly trained, and number three, certified if and as required by state and federal laws and regulations. We could devote a whole program to choosing and designing your mixing and loading area, but just to reiterate some of the simple basics, it should be outdoors or somewhere where there's good ventilation, away from people, animals, food and feed, other pesticides, and anything else that you should worry about contaminating. It should be located near a sensitive area, for example. Be absolutely certain that you have good lighting and good ventilation. Make sure you have all the things you need to do the job. Opening, measuring, mixing, loading. And be sure you have the equipment to deal with the spill if one should occur. Protect your water sources by preventing back siphoning, whether that's as simple as using an air gap or a more complex piece of equipment. Always be sure that you're taking pains to protect water supplies. Before you start, make sure you have and put on all the personal protective clothing and equipment that the label calls for. By law, you have to do this. In addition, consider extra in certain situations. For example, even if not required, an apron and face shield will provide extra protection from chemical splashes when you're handling liquids. A respirator will give you extra protection when handling dusts and volatile liquids. Careful when you're opening pesticide containers. If they're made of paper or cardboard, be very careful that you don't rip any inner lining or cause the product to be expelled rapidly because you were careless. When you're opening a liquid container, make sure it's stable when you try to remove the lid. If it's big or heavy, ask for help if you need it. Many spills and splashes occur when people are first trying to open a container, so that's a time to take special care. When you're pouring a pesticide out of its container, work well below face level and consider which direction the wind's blowing from. Those are two simple steps that will go a long way to reducing your exposure. When you use a closed loading system, be sure it has a pump or some other suction device built in. Never, ever attempt to siphon pesticides from a container into a tank using your mouth to start the siphon. That's an excellent way to get a mouthful of pesticide, and it's an extremely dangerous practice. Close containers and put them away after you use them, even if you plan to use more of the same soon. Never ever leave a tank unattended while it's being filled. I think this picture shows quite graphically why that's so. You never want to overflow and contaminate your work area, your water source, or both. Part of your plan should be to have the materials you need to clean up spills and decontaminate yourself if something spills or splashes on you. At a minimum, wash thoroughly with mild liquid detergent and water as quickly as possible if anything spills on you, and put on clean clothing and protective equipment. Then clean up whatever spilled into the environment. If you plan to tank mix 2 or more products, check the label for any guidance that it provides about whether this is possible, and regardless, do a jar test to make sure that compatibility isn't going to be a problem. When you move pesticides from the mix load site to the application site, whether that's across the yard, across town, or across the county, make sure they're secure and you're doing it safely and legally. People talk about pest management, but if you use pesticides to control pests, you have a responsibility to manage pesticides as well. Protect people, protect the environment. And you can do this by making sure you follow the label and use pesticides carefully and correctly. You're required by law to use all the personal protective clothing and equipment that the label requires. However, extra PPE might be a good idea, especially in high-hazard application situations. And these include when using handheld equipment, entering the path of just released pesticide, or walking into a just treated area, as you often have to do with handheld equipment, making an application in enclosed spaces, adjusting or repairing application equipment, applying concentrates, and making an application overhead. People who plan to use a pesticide have thought about pest management, certainly, but they also need to think about pesticide management. There are many factors to consider if you're trying to make sure pesticides are used properly, safely, correctly, and one is to consider timing. Timing can mean, is the pest that you're trying to control in a life cycle stage such that the product you've picked will work? Another aspect of timing, though, is the weather. Are the temperature and wind conditions such that this application can be successful. Always think about safety for both yourself and the environment. You can find on the label guidance about timing as far as pest stage. You can find the same thing about timing as far as wind, temperature, or weather restrictions that would impact your application. Every time you apply a pesticide, it's your responsibility to make sure that you've configured your equipment to do the job and do it right. It should deliver the pesticide to the target, avoiding non-target organisms or surfaces. It should also apply the pesticide at the right rate in the right distribution pattern. Last but not least, it's your responsibility for your sake and for that of those around you in the environment to operate that equipment properly and safely. A good way to do that is to establish an application pattern and check your rate and delivery system often. Make sure things are uniform. Watch what you're doing. It helps to use an indicator or colorant. That helps you operate your equipment safely and efficiently. As soon as you finish a pesticide handling task, clean up. Wash your equipment, including any PPE you used. Wash yourself. Put everything back where it belongs. Make sure excess product is put back properly in careful storage. Make sure any empty containers have been rinsed and are ready for disposal or recycling. Make absolutely sure that the places where you worked do not present a hazard to other people or to the environment. While you can still remember what you did, make a record of what you applied and double check the conditions of the work site. Be sure to handle empty containers properly. I say empty, but even a drip drain pesticide container still has residue. If you have rinsable containers, make sure you jet or triple rinse them and offer them for recycling if at all possible. Dispose of them properly if not. If the container is not one you can rinse, return it to the supplier if it's returnable, refillable, or dispose of it according to label directions. Keep records of pesticide use. In many cases, this is a legal requirement, but even when not, it's a highly recommended practice. Good records can save you time, save you money. First of all, they'll allow you to evaluate the effectiveness of controls you applied. Did they work? Didn't they work? If not, why not? What would you do next time? It can help you resolve pesticide failures in some cases. It can also help you with inventory. It can help you figure out how much you're going to need for a day, for a month, for a year. It can improve your ability to buy the right amount of pesticide. It can allow you to make good plant management decisions. For example, if you know what persistence carryover is likely to be, it can help you know what crop rotations you can use. In case of a problem, it allows you to document legal use. And if good records show proper use at the right time, at the right rate, in the right manner, under the proper weather conditions, you may not be held liable for problems, even if they are the result of your application. It can allow you to provide necessary information in case of a medical emergency. Last but not least, it's true that knowing who uses what and why allows USDA to provide EPA with information needed to support critical registrations and know what pesticide uses are key to a particular industry or production or whatever. As is the case with designing a proper mixed load site, technical information about designing and managing proper storage could take an entire presentation, but at a minimum, it ought to be secure, high and dry, well lit, and well ventilated. It should be big enough that you can move around and work safely, and big enough to allow for separate areas for herbicides, fungicides, and insecticides. It ought to include one other component too: information, a list of the pesticides you have in storage, along with labels and material safety data sheets for each. After every application, follow up. Visit the site and inspect the treated area. Evaluate and record the efficacy of the application. Identify any problems such as off-target movement and look for unexpected results or problems. Anything you find should be documented. In summary, it's your job to be a responsible pesticide manager. Always read and follow the label. Always use best management practices in every step of all pesticide handling operations. Transport, mixing and loading, applying, storing, and ultimately disposing of unwanted products and empty containers that result from your pesticide application practices.
And that's the end of our presentation on mixing, loading, and application. Thanks for listening.
So basically, keep records and don't work with the stuff near something that could be contaminated.
That's one of many things, Tyler. Carol, can y'all hear me now?
Yes.
Okay. That was a sort of a quick one that Tech put together, and we're going to spend some time on Wednesday looking at different types of application equipment. It may be a little bit cumbersome to do, but I think we'll have to switch on and switch off, because normally I've just done it here with this class, but with this transmission to down there, it's going to make it a little bit more of a problem, but I think we can do it.
Okay.
Just to show you different types of equipment, because they're all over the board, and there were, in that little video, there were 12 or 15 different types of application equipment that was used. And I want you to gain an understanding of that and be comfortable with the different types of things that are used to apply. They can be as simple as a Windex bottle that you put a solution in and squirt out manually, or it can be one of the pieces of equipment like Mr. Parrish was using, or some of the other more sophisticated things. But we'll talk about that on Wednesday.
What's the name, Chuck?
You guys have a nice day, and we'll see you then.
Okay. Thank you.
Thank you.
And in answer to your question, Tyler, I didn't see an email from you unless I actually answered it last night. I don't see it in my inbox.
All right.
Thanks, Tom.
Yep. Okay. Bye. See some of y'all later.